All right, so yesterday in our lab, we looked at pairs of things that form precipitates and pairs of things that don't. And so we were looking at, okay, if I mix lead ions with chloride ions, that gets me a precipitate. But if I mix copper ions with chloride ions, that doesn't. Okay, so what we're getting at here is the idea of solubility. So water will dissolve most ionic compounds, but not all of them. So down here we made a list of all the things that it wouldn't dissolve and then all the things that it would. So you'll notice that the list of things it would dissolve is much longer than the list of things it wouldn't. And that's pretty true about water. Okay? If the attraction of the water is stronger than the attraction of the ionic bond, it's going to break apart and dissolve. Okay? If the attraction for the ions is stronger than the attraction to the water, then it's going to precipitate out in a solid. Okay? So the first thing I wanted to point out to you was a few patterns that we could notice here. For example, there's a common thread through here. We've got lead, 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 lead. Most of the compounds with lead are not soluble. The exception to that, of course, is the lead nitrate. But of all the things that we mixed with lead, that was the only exception, was the lead nitrate. So for the most part, lead is never soluble, no matter what we mix it with, except for maybe like nitrates. Okay? Another common culprit is silver. We have silver, 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 silver. Okay? There were a few places where we had silver over here that was soluble. We had the silver nitrate and the silver sulfate. Okay? But for the most part, silver is not terribly soluble either. Okay? The carbonates, those CO3s, look at all these endings. CO3, CO3, blah, blah, blah. There was only one that didn't form a precipitate, and that was the sodium carbonate. Okay? So carbonates are usually not soluble. So what I want you guys to notice from the lab that we did yesterday is that we can actually kind of start to identify certain trends of things that are either usually not soluble or usually soluble. Let's look over here. OH, 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 OH. Almost all the OHs ended up being soluble except for the two that were with the lead and the silver, who usually aren't soluble. So usually hydroxide is soluble. Iodine, I. The only two that weren't were the lead and the silver. So I is usually soluble. Phosphate, PO4, 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 PO4. We only had the lead and the silver that weren't soluble. So you can start to see that there's lots of patterns. Look at all these NO3s. None of the NO3s, even the lead and the silver, none of those precipitated out. They are always soluble. No exceptions to that. Sulfates, usually soluble. Almost all of them were soluble except for a few. This time we added barium instead of silver as being our insoluble one. Chlorides, usually soluble. A couple exceptions that we really expect. So you can look at this data and you can start to see that there's actually some patterns and trends. There are some things that we can say are almost always insoluble. There are some things we can say that are almost always soluble. And that brings us to the solubility rules. So you guys should have this on your reference chart. Sorry, I know there's a glare. Let's see if I can get rid of that. There we go. So on our solubility chart, it tells us that group 1 metals and ammonium are always soluble with no exceptions. So if you have a group 1 metal, it does not matter what it is bonded to. It could be a sulfate, it could be a carbonate, it could be anything. It's going to be soluble, no exceptions. Nitrates and acetates, and they've given you the formula here, NO3 and then C2H3O2, always soluble, no exceptions. Chlorates and chlorides, ClO4 and ClO3, always soluble, no exceptions. Halogens are usually soluble. There are 3 exceptions: silver, mercury, and lead. Okay, which explains what we saw over here on our lab. Okay, the halogens, that's your iodine and your chlorines, were all very soluble except for the silver and the lead. We didn't actually test mercury with them. Okay, so that actually matches perfectly with what we saw in the lab. Sulfates, SO4, those are almost always soluble. That was what we saw in our lab too. There are more exceptions here though. We have calcium, barium, strontium, silver, mercury, and lead. So Sulfate is going to be soluble unless we have it with one of these things. And then cyanide, CNs, are always soluble with no exception. Then there are some things that are always insoluble. They're always going to precipitate out. Our carbonates, our sulfites, and our phosphates are always insoluble unless they're with a group 1 or ammonium, because those are always soluble with no exceptions. So these three things are going to be soluble no matter what we pair them with, or excuse me, are always going to be insoluble no matter what we pair them with unless it's a group 1. Hydroxides and oxides are usually insoluble unless we have a group 1, ammonium, or a good chunk of group 2. Calcium, barium, and strontium are all group 2 elements. So those ones are going to be soluble. Sulfides are insoluble except group 1 and group 2. So any sulfides that are in group 1 and group 2 are going to be soluble. And then ammonium. And then chromates, CrO4, insoluble except for groups 1 and ammonium. Okay? And we didn't actually do chromates in the lab yesterday, but. So an important thing to note, you're going to look at your compound, you're going to find which piece you have, and you're going to look at this column. Soluble means it's going to be aqueous. Insoluble means it's going to be a solid. Okay? Then you're going to look at the exceptions. If you have something that's on the exception, it's going to reverse this word. So let's say we have a sulfate. Well, that's soluble, but the sulfate we have happens to be attached to barium. That's going to change it from soluble to insoluble. So the same is true down here. If I have a hydroxide, that's going to be insoluble unless it's paired with barium, and then it becomes soluble. All right, so that's kind of, if we have something that's over here, it makes this word backwards. All right, so let's do a few examples. You guys should have this worksheet. So let's start with this one. We have copper nitrate. So we're going to take this apart into Cu and NO3. Okay, so we have Cu and NO3. Then we're going to look at our solubility rules. Okay, we don't really have copper over here. It's not a group 1 metal. Okay, so let's look for the NO3. NO3 is right here. It's a nitrate. Soluble, no exceptions. So for this one, I'm going to write, for soluble, we always write a little AQ, saying that it's aqueous in water. Sorry, that's really blurry. There we go. So we write a little AQ. That means aqueous in water. It's going to dissolve. All right, so now let's do this next one. We have Mg and then CO3. So we're going to take that apart into Mg and CO3. So we're going to look for magnesium. Magnesium is a group 2 metal, so not there. So magnesium's not on here, so now we're going to look for the CO3. Let's look for the other part. The CO3 is on here. Carbonates are usually insoluble, except for group 1 and ammonium. Well, magnesium is not group 1, it's group 2. So we are not reversing this word. It is insoluble. So magnesium carbonate is going to precipitate out. So we're going to call that S for solid. On this one, we have NH4 and Cl. So you see what I'm doing? I'm just kind of taking it apart into the two ions. So let's start by looking for NH4. NH4 is the very first box. NH4 is always soluble, no exceptions. So we can go ahead and say that this is going to be aqueous. Okay. The next one we have is NaCl, so that's going to break apart into Na and Cl. Okay, so let's look for Na. Na is a group 1 metal, and group 1 metals are in this first spot right here. Always soluble, no exceptions. So it doesn't even matter what the sodium is bonded to. It's always soluble, no exceptions. Okay? So that's how we do this top part up here. All right, to do this bottom part, I'm going to zoom out just a little bit so you can see better. They've given us a whole equation. And they've said, using your solubility rules chart, label each compound in the reaction. Label if they are soluble, aqueous, or insoluble, solid. Then identify each reaction as either precipitate or no reaction. If it is a precipitate reaction, circle the precipitate. So next to the word precipitate, I want you to write solid. Remember, we talked about this in lab. A precipitate is a solid. So anything that comes out as an S for solid means it's going to be a precipitate. All right? So we have Na and we have SO4. Na is a group 1 metal. Those are always soluble, no exceptions. So sodium sulfate is going to be aqueous. Then we have Ba and Cl. Ba is a group 2 element. Group 2 elements aren't on here, so let's find the Cl. Chlorides, where are you, my friend, is a halogen. Okay, they are soluble. There are 3 exceptions, silver, mercury, and lead. We don't have silver, mercury, or lead. We have barium. So that means that this is going to remain soluble. So for barium chloride, we're going to label that as AQ. Okay? Then we formed NaCl. Again, Na is a group 1 metal. When we looked it over here, it said always soluble, no exception, so it doesn't even matter what it's bonded to. We don't even have to look. Barium sulfate. So now let's look up the SO4, because we established barium's not on there, but let's look for SO4. Sulfates are soluble except for, oh, there's barium. It's an exception. That means it reverses this word. So instead of being soluble, it's going to be insoluble. So barium sulfate is going to be insoluble S. Okay, remember S means solid. So it says to identify the reaction as either a precipitate or no reaction. Okay, well, since we formed a solid, this is going to be a precipitate reaction. And then it says, if it is a precipitate reaction, circle the precipitate. That's our solid, so we're going to circle the barium sulfate. Okay? All right, let's look at number 2. HCl. All right, hydrogen is not on here, but chlorine is. It is soluble except for silver, mercury, or lead. We don't have any of those, so this one is going to be soluble. Barium chlorite, ClO3. Let's go find our ClO3. There it is. ClO3, soluble, no exceptions. So that one's going to be aqueous. We just said ClO3 is soluble with no exceptions, so we can call that soluble. Then let's go find our chlorides. Chlorides are soluble except for silver, mercury, or lead. We don't have silver, mercury, or lead. We have barium, so this one is going to remain soluble. So all 4 of these were aqueous. So we have no precipitate. So this is going to look like no reaction. Why do we say no reaction? Well, because nothing observable is going to change. Since they're all staying dissolved in water and they're not forming anything that isn't soluble, they're all going to look the same. There's going to be no visible change, just like the ones that we had yesterday in the lab that had no reaction. All right, so you're going to want to continue practicing with this. Keep on going.